Let's see, let me see if I want to do this one or come back to it. Hang on. Okay, let me go back to that. But calcium's important, and then I'm going to shut up. Okay, if you look at our little model here, you see these are sarcomeres in here, and they're covered with some sort of like brown-looking kind of looks like a sock with a bunch of holes in it, right? This thing that's covering the sarcomeres is called the here it is. Terminal cisternae, something else. This blue thing on this slide that's covering the sarcomeres, you see the sarcomeres in the background. This blue thing that covers the sarcomeres is called the sarcoplasmic reticulum. Now I told you that calcium is important in muscle contraction. All right, where's it stored in your muscles? Right here. Right, it's stored, calcium is stored in the sarcoplasmic reticulum of our muscles. When the muscle gets a signal to contract, calcium is released from the sarcoplasmic reticulum, which is right there on top of the sarcomere, and causes the troponin and the tropomyosin to move, and the muscle contracts. Makes sense. I mean, why would you store calcium somewhere else if you need it in your muscles? So it's stored in this structure called the SR, the sarcoplasmic reticulum. This thing called the terminal cisternae, since it's on here, I'll show it to you. You see there's like this little kind of, it's called a T-tubule. We'll get to this in just a second. This is a T-tubule. On either side of it, there's this kind of like expanded area. It's called the terminal cisternae. But the sarcoplasmic reticulum is where the calcium is stored, because that's where you need it. So on this model, and I know you'll be looking at this time, on this model, these little blue things are T-tubules. The little brown webby stuff on there is the sarcoplasmic reticulum. But what's the deal with the T-tubules? Right, well, here's the deal with the T-tubules. Why does muscle contract? Because it gets a signal from the nervous system to do it. Well, okay, great, I get it. So if you stimulate a muscle, the whole muscle contracts. I mean, if you stick your finger in an electrical outlet, the whole thing's going to contract, not just your finger. Well, how does the signal to contract get from the surface all the way down inside the muscle? Through the T-tubules. The T-tubules are like conduit, you know, they're like, it's the pathway to get the signal into the muscle, right? So this is so cool how this works. So here's the signal coming into the T-tubule. Well, as the signal comes into the muscle, say to contract, it comes into the muscle through these T-tubules. Well, where are the T-tubules? Well, they're right here in the sarcoplasmic reticulum. What's in the sarcoplasmic reticulum? Calcium. What do you need to contract? Calcium. So the whole thing is a nice, neat little bundle here. The T-tubules transmit the impulse into the muscle, causing calcium to be released here, bingo, right here, the muscle contracts. And then it relaxes, just like that. Yeah?
So the function of the calcium ions is just to cause contraction of the muscle?
It is. Let me go back. The basic idea is this, and we'll start with this tomorrow night, but the basic idea was this. Contraction begins with the release of calcium from the terminal cisternae of the sarcoplasmic reticulum. Now, what happens when calcium is released is the calcium actually interacts with the troponin and tropomyosin to cause those molecules to move, exposing the binding sites and allowing, movement in the muscle. Now I've got a video, a little tiny video I'll show you tomorrow night. I've got to find it somewhere, that shows you how this all works. So calcium is important. You've got to have it for your muscles to contract. Now there's other stuff that's important as well, like sodium and potassium and things like that, but that's more at the nervous system end. But the calcium is the key. You've got to have that stuff in there. Make the muscles contract, to allow them to contract.
Say that again.
Sure.
When the calcium is released, it binds to with the troponin.
Yeah, so here you go. What happens is when calcium is released, it interacts with these regulatory proteins, the troponin and tropomyosin. And those proteins move, exposing the binding sites on actin, and then the myosin can interact with it. No calcium, no exposure of binding. No exposure, did I say? Yeah, exposure. Exposed. I was trying to get the right word here. They just move, right? So they're exposed. Yeah, I guess that's the word. Right? So you need calcium to get the binding sites in a position where binding can occur. So calcium is one of the keys here. And we'll talk about how this all works tomorrow night. I'll find that little video I want to show you and show you exactly how the little myosin heads move, you know, and how the little troponin and tropomyosin molecules move. I guess now that I think about it, it probably did take, you know, a long time until the middle of the 20th century to figure out how all this stuff works, right? It's pretty complicated. So let's finish off with dinner. When you eat skeletal muscle, see, I'm turning you vegetarians, you leave this class. Probably not. What do you eat? Well, you eat skeletal muscle, you're eating actin, myosin, all that stuff. Yeah, Michael, good.
So the nervous, to contract the muscle, it sends a signal and then it goes through the T-tubule, which activates the calcium to be released, which causes the muscle to contract.
I think that sounds about right. So, but now let's do it this way. So you're looking at your biceps, and you're going, okay, I want to contract my bicep muscle, and your brain says, okay, contract, right? Well, you know, it happens instantaneously, and so when you do that, calcium's released, the sarcomere is shortened, right? And then you go, okay, let's relax that, right? Calcium's reabsorbed, the muscle relaxes. I was reading this video that I can't find anymore called Supersize She. It's about this lady who's a professional bodybuilder, who's obviously using testosterone, and, you know, to get this look. She's got, you know, a lot of definition and stuff. But something I didn't realize that this video goes into. She was training for a competition, and you know, she had to. Although it's hard to believe, she had to actually sort of lose weight, which seems impossible if you look at her. Anyway, to get some sort of weight, whatever. But what they were saying is, when in any of these competitions, but these ladies doing it, you've seen these things, I know. You know, they have all the, you know, the poses, you know, all that kind of stuff. But when they're actually doing their routines with the poses and stuff like that, they're actually extraordinarily weak because they've been dieting, they've been, you know, dehydrated, they're trying to, you know, get this very defined look, but just like holding this for a fairly short period of time is exhausting, just because their bodies are in a well, it's, you know, unnatural in that sense, you know, to put yourself in that sort of depleted, you know, kind of situation. If I can find it, I'll show it to you guys. It's kind of long, so I never show the whole thing. But so she goes off this contest, like in DC, and you know, she's from California, and she gets in this contest, and there's like 8 women or 10 women or